Gentlemen, but he's a lady here, so gentlemen. So good evening, Maharaj. Yeah. So this is Chirantan Gupta. So I'm a data scientist from Shell, which is an oil and gas and energy giant, as you know, in the Fortune 500 company as well. So we are going to talk about today. We are going to talk about graph databases. Mostly, we'll focus on not just only graph databases, but we will also focus on other areas. Like, for instance, we will focus on why we are using graph databases, which is the most important question that will come. So as we will go down the agenda, this is what it is: introduction to graphs. I think you are all aware of what it is and what is the need of it. Why are we transitioning from SQL databases or standard databases, RDBMS, to suddenly to graph databases? What is the need of it? Then we'll talk about Neo4J, and which is something which we'll talk about. What it is, I'll talk about, and some commonly used queries, and what is RDBMS, and what is the difference between this and the graph database. And we'll get into the 3 use cases, as you see: analyzing the criminal activities from crime data using Neo4j, and then analysis of Stack Overflow data using Neo4j and Python. All of them are from using Neo4j and Python. I'll show you. And sample call data records analysis using Neo4j and Python. And by the way, if you are having any question anytime, please just pause me and ask me. Yeah. So shall we move on? Yeah. Okay. So this person was the first person who actually gave us the concept of graphs, what we know as today. I mean, Eulerian tour or Eulerian cycle, as we are all aware of, this is basically what where this thing has come from. And in fact, this city, what is now I think called Kaliningrad, and it was called Königsberg back then. And this particular man, Leonhard Euler, he was the first person to have come up with this concept of these graphs. You know, this is basically the 7 bridges problem. I think you are aware of this problem, Königsberg problem, 7 bridges problem. This is an iconic problem, historical problem, and he used the graph theory in order to solve this. And he showed, not he, later on other graph theorists, they have shown that it is not, you cannot actually start from one particular node and come back to the same node and cross all the 7 edges, so to speak. And so it is not possible to do that. So he showed that. But we know that this one is not like that. For this one, you can actually traverse across the entire graph. For instance, if you go through the alphabetic order from this node, if you start from this one, from here, you go to this one, and from here to this one, so C, then D. You can, by the way, visit a node again. It's not that, it's only that you cannot visit the edge again. You cannot visit the edge again. One edge cannot be visited twice, which is the basic principle of Eulerian cycles or Eulerian path tour. So you start from this node, you come here and you go here, then come here, and then again go here, then go to this node, visit this, you traverse this edge, then you come to this one, and from here you go to this node, and from here you go to this node, and from here you go to this node, and finally you go back. So what is the speciality about this node, this graph and this graph? Why is it not solvable? And why does it have an Eulerian cycle? And why does this have an Eulerian cycle? Can anybody tell me why this is so? Any idea? What is the difference? Why is this having an Eulerian cycle, and why is this not having? Well, this is because this one has odd degree for each node. And in order to fulfill the criteria for an Eulerian graph, you have to have even degree, or 0 or 2 nodes can at the max have odd degrees. So this is the basic criterion. In this case, by the way, all of them are having even degrees, 1, 2, 3, 4. This one also 2, and so on. So moving on, this is what it literally is. So the question is, why do we need a graph? If I ask you the question, what are the two basic things that you see in a graph? Vertices and edges, right? There's nothing else apart from that. Now, what do we get out of it? What do these edges mean? If I were to ask this question, what do these edges mean? If I have to create a model out of it, what do these edges mean? They mean nothing else but relationships. Either we are talking about social networks, we are going to talk about a lot of things today. Relationships, how this node is related to this node and so on. We'll get to that. So now I ask you this question. This is something which you call a graph. This is also something which you call a graph when you plot it. Why do you call this a graph? And what is the basic difference between this one and this one? The answer lies in the last slide. If I ask you this question, you all have done this in Matplotlib or in R, you have done these plots. So now tell me, you are well aware of these two different types of graphs, but tell me, why is this called, this is different, or how this is different from this one? Absolutely. And here, you cannot find out what is the relationship between this labor and license. Can you find out any relationships? You can't, because based on whatever we are given here, we can't really find that out. Similarly, for this case as well, from the scatter plot as well, we can't. So this is as simple as this. Okay. By the way, this is basically from Neo4J. I'll get to that. By the way, I'm not going to show you how to download or install Neo4J today. You have to see that for yourself. I'll tell you where to do it from, but you can just check the web and do it. Now, those who are well acquainted with natural language processing are well aware how to semantically parse sentences, right? This is what we call dependency trees in natural language processing, which we all have seen, right? So here you see that the sentences are basically, as if you will, partitioned into noun phrases and verb phrases, and this now in recursive way we go down the tree, right? So this is exactly what we are doing the same, using the same concept of graphs there as well. I mean, if you see, if you are aware of how dependency is, suppose if I say, what letter can come after Q? What is the letter that can come after after Q, only two letters can be. Either U, as if Q-U-I-E-T, or quite, right? Or you can have what? You can have something like Q-E something, maybe Q-U-A-L, qual, or something like that. Q-E can also be there. So there are only two, three letters that can come after Q. You cannot put an M after Q. You cannot put a B after Q. That can never happen. In all languages, they have a basic structure like that, right? So this is what we call dependency. You know, you can't just simply go and put any letter there and say that this is what I found a new language or a new word. You cannot do that. You have to follow that particular grammar, right? So I think you are all aware of languages. In fact, in languages, the basic concept is that in languages, you will find that if suppose when you find the frequencies, when you don't know a language, what will you do? You will try to find out, suppose the letters of that language is not known. Let's say Harappan civilization language. You don't know that. So what do? You will search for all the words, all the frequencies of all the different symbols that comes after this particular symbol. And in this way, you keep on going. And that way you can come across with something meaningful, that this is something which is found in some cases, and this is which is not at all applicable. So this is exactly the way we do the whole thing. So, so ultimately it boils down to the fact that graph is a connected data. Okay, so like roads, we have lights, we have traffic. So roads are connected to the traffic lights, and then traffic, the vehicles are commuting along the road, and they have to obey the lights. But there's a catch here. There is no relationship between these traffic and lights. But these vehicles do have to obey the rules of these signals, right? Without that, there would be accidents and many other things. We'll talk about these hidden relations. I will directly show you these hidden relationships. How can we identify them? And suppose you go to a hotel has rooms, and then whether the rooms are available or not. Now, you do not know the hotel and the availability, there is no relationship between them. Rooms are available, but hotel is available or not, it is not saying anything about it. Hotel has rooms which is available, right? So this type of relationship is what we try to create in general with a connected data. And this is what we try to model using graphs. And finally, we arrive at something horrible like this. And this can be even more horrible if you try to see something which like Twitter data, Facebook data. When we talk about big data, and we'll come to that, this is when it will become really, really enormous. So most successful companies like these are the LinkedIn, Google. I can think of these LinkedIn, Google, Meta, which is very popular nowadays for firing people. And they are basically, they use Neo4j, but they haven't given up on the traditional databases as well. They're using the databases as well, okay? So today we see graph projects in virtually every industry, finance to retail, social networks, HR, recruiting, healthcare, telecom. We'll talk about telecom today. We'll talk about social networks today. And we'll talk about maybe there is something different. I think those two things will come under social networks. Yeah. Okay. So the first thing that comes in our mind is what is this? What graph databases are? We say that not only SQL. So why it is not only SQL? Because just using SQL, what we are doing, we are basically joining tables. We are retrieving relationships. Like if you join two tables and then you find out like this is a key, foreign key there is in one particular table, and there is another table where with which you can join that, and this way you can continue. And this process is very complex at times. We'll see that why it is so complex. So firstly, the data set size. If it increases, you will have a lot of miseries in your life. First thing. Then normalization. What is meant by normalization here? When we try to normalize something, so what we do is that we try to break the bigger structures or bigger tables into smaller tables. That's exactly what we do. But from 1NF to 2NF to 3NF, we just try to do that only. Now, this is a very expensive process. And again, if you want to find out a relationship, who is the employee who was working in that company between 1994 and 1998, let's say in TCS or whatever, and then you try to find that relationship out, and you will see that, oh my God, there are 15 tables are there, and I have to literally hop from one table to another, and then I have to basically join them all and then write a huge SQL query in order to do that. That's really disgusting. So we don't want that. So now the other question is, if we want to find out complex models, complexity arrives at when you come across these relationships, mostly. Relationships when we talk about who is present at this particular, let's say in this seminar hall, who are the people present here? How am I related to these people? And how are you related to somebody, let's say in my company, in Shell? Let's say somebody who is my general manager in Shell, how can you be related to that company? Yes, there is a way. That let's say you also have an account in LinkedIn. Okay, I don't have an account in Facebook, by the way. So if you have an account in LinkedIn, you will probably find me there. And if you connect with me, you will be mutually connected with that particular person as well. So this is the type of relationship. But if you try to do this with the traditional databases, it will definitely make your life a little bit more complex. We'll come across this particular thing. So complexity comes whenever it's basically a function of size, connectedness, and some sort of the structure. Now, examples, I think this is a perfect example. This is something which you all have seen on the top of the doors on local trains or in the metro railways. And this is something which and this also can be modeled by graphs. So this one, you're all aware of this. This is in Amazon. So those who bought this also have bought this. So suppose I have purchased, let's say I have purchased a particular thing for my mother. Let's say a chair. So a particular chair for my mother. So naturally what will happen is that after that, it will keep on showing me recommendations of different furniture. Yeah, it will not show me recommendations for, let's say, laptops, but it knows my age. It knows my data. I mean, where I'm working and all these things. I've shared that in Amazon, right? So they will know about it. And when they get to know about it, they try to put you into a particular cluster. We'll come to what that is, into one particular bucket, and they'll try to see what most of the people in that age group in that particular bracket are doing at the moment. Yeah. So based on this concept, a lot of things are there in that we have. If you, an example, all of you are aware of this Rangoli Mall, right? That is quite expected. And you are, have you seen how things are placed over there? I mean, there are grocery items, and just beside that, have you seen that baby diapers are also there? Have you seen that? I mean, you will find these types of oddities over there. But why is it there? The question will be, why is it there? Why is mushrik dal, mugir dal, and after that, suddenly a baby diaper? What is the reason? I mean, there must be a reason behind that. So the reason why it is so is because somebody who is going there, let's say a person who is going to these particular shops in order to buy something, women whose age group are between 30s or between 30s, 40s or beyond, men also within that age group. So these people will obviously have children, and obviously they will require these diapers and all these things. So this is something where you will find that there is a relation. That diapers are somehow, if they have purchased this, they will also purchase. Then this is what we call market basket analysis. In this way, we see that in each transaction, how many different types of items have been purchased, what is the frequency of it. If you see that the frequency of it is very large, that mushuri dal with diapers, if this is very large, then definitely you will do it. But you will obviously see whenever any person goes to any mudid dokan or anywhere else, we will obviously do what? He will obviously go there and say, দুটো ডিম দাও, মুসুরির ডাল দাও, তেল দাও, ব্যাস, আর চাল দাও, 500 গ্রাম. This is exactly what you will see everywhere. So this combination is universal across at least Bengal. So this is by the way, a Twitter network, social network. Yeah. Okay. So we have these, why am I saying this? I'm just reminding you of this: atomicity, consistency, isolation, and durability, the acid properties in DBMS that we have. And these are important because what I'm going to show you after this, this property will come into, these 4 properties will come into very important, utmost importance, I should say. Okay. So Neo4J is basically an ACID compliant transactional backend. By the way, it is a backend. It is written in Java, okay? And it uses Apache's Lucene 3 for indexing and searching. It's by Lucene is, by the way, a text search engine, and that also is written in Java. And the developer, and this is what is basically according to the Neo4J website, it is disk-based, embedded, fully transactional Java persistence engine that stores data structured in graphs rather than in tables. And the developers also claim that it is exceptionally scalable, has an API that is easy to use, and we will see that. So what makes the Neo4J the easiest graph to work with? This is because we have something called Cypher, not to confuse with CIPHER, Cypher, in your cryptology. Probably you have heard that or taken a class, attended a class. This is a query language, just like SQL. This is also a query language, but optimized for graphs. And it is so much optimized, you will see that this optimization, it is very meaningfully optimized. Just like you have something like whenever you say that this is related to this, we'll see that this particular, when we are saying this in English, this is exactly how that we will be able to translate into the query language cipher as well. Then constant time traversals across bit graphs for both breadth and depth due to efficient representation of nodes and relationships, and flexible property schema, graph property schema, and drivers for popular programming language, including Java, JavaScript, .NET, Python, and many more are supported. I mean, from here, you can run them. We'll also see that. So why is Neo4j? Because you can directly see the relationship that this is a person, this is another person, this one writes this one owns this one. So naturally, this person, the left one is the driver, and the right one is the owner. And this one loves this one loves this one, is a perfect world and lives with this one. And so perhaps this is basically the husband of this person. And so naturally, this is a very happy situation we are in. But we will not always get a happy situation like this. How else do people do this today? Using relational databases with expensive join operations or cross lookups, often tied to a rigid schema. Now, relationships are stored natively alongside the elements in a much more flexible format. And graph databases addresses big challenges for many of us to tackle daily, navigate across deep hierarchies, find hidden connections, etc. So how do you actually find this particular thing? I mean, this is exactly what a cipher query looks like. We'll delve more into these cipher queries as we'll move along. That this is this person is basically like a class, like any C++ or Python or Java class, any class you create, class A, class B, whatever. And this is basically the object. I mean, you can say that a small p is a type of person who has this property, and this name, the property name is name, and the value is Dan, just like what we have in JSON, right? In dictionaries, you're all aware of what it is. And this, again, this relationship is again also, you can have a variable here, or object of the type relationship, which is loves, by the way, and whom, that is a variable. This is basically a variable. Return whom, that is love someone. And this is again another object. You can say this is a type of the object person, class person, and you can return whom. So nodes are the entities, as you have said, and nodes can hold any number of key value pairs or properties. For example, we can have names, you can have so many other information in the properties. And use cases, we have real-time recommendations like that who has purchased this, who has viewed this, who has bought this, and so on. So Walmart, or you can have anything which is there in Amazon. That one will be your real-time recommendations, fraud detection. We'll get to this part. I'll talk about how we can track criminals from crime data. I've written a program on it, and I'll show you that one. And I mean, suppose this is some sort of detective, and this is, or maybe this is a thug, and this is a detective. This criminal has opened an account here, has a credit card, and has opened an account here, and he's issued another credit card. I'm sorry, this is I think opened an account here, and has issued with a credit card here, lives here, has something like a possession, a camera or something. I don't know what this is. And then this person also is having the same thing, and God knows why they are both staying in the same house. If they are criminal, he's the criminal and he's the spy. I'm seriously not able to see why they would stay in the same house, and then we want to find out any relationship between them. Okay. By the way, if you find out something like graph-based search, which is probably there, what you'll find in Google, like, for instance, whenever you search for a particular thing on Google, you will find there is a popular algorithm, what we call a PageRank algorithm. But PageRank algorithm also is very much optimized today. Nowadays, you don't actually, you get that thing in literally or constant time. It is, I mean, any search engine would probably think about how is it able to do so. This is a popular question. I mean, PageRank algorithm was the one which was used, and it's still used, but there are these graph structures are also there, and these relationships. I mean, if you search for, let's say, something like Elsevier, Elsevier, you know, there's a publication house, Elsevier, which publishes these different research journals and papers. The next time when you will open with the same account, you will be showing, if you don't even open with that account, your IP address will be used and they will give you recommendations like IEEE. You want to see this, you want to see that. And based on your your history, it will show you recommendations. So this is entirely based on this graph-based search. So this is what it looks like. Network and IT operations in all the companies now, Accenture, HP, all these companies, they're using these network and IT operations. And that is this particular language or this Neo4J has come into existence in 2015. It's not very something which is very, very old or something like that. And again, not even very new. It has little bit of problem regarding the community that it has. Like, for instance, if you are stuck at a particular line, you will probably face a problem like the way you can search for something when you have any problem with Python. Let's say you are trying to unzip a file in Python and want to see what are the different files present there, and you want to open all these files, and then you want to actually read the data from them and store them in a list of database pandas data frames. So this whole exercise, you can see this, I mean, if you are not knowing this, maybe the syntax, but you want to do this, you know what to do, and then you can search on the web and you can easily see that somewhere in Stack Overflow. The answer is there, right? But for Neo4j, it is a little bit difficult. So that's why, as it is 2015, originated in 2015, you will probably see that certain certain syntaxes changed, and that doesn't work. And I also stumbled upon those things while writing codes. And identity and access management, who trusts whom, who authenticates whom, who can read this, who can own this. Like you have read in operating system, like when a file is being, let's say it is in a particular folder which you don't have access to, you try to enter there and it will tell you directly that you don't have the access to read or even access that file at all. So these types of data. So whenever we are trying to represent the data in relation to the databases, it is good for well understood data structures that don't change too frequently, known problems involving discrete parts. And this is good for this Neo4j. This is good for dynamic systems where the data topology is difficult to predict. Dynamic requirements and problems where the relationships in data contribute meaning and value. So this is what it is. And so labeled property graph. So this is, as I was telling you, this is a type of a person. This is a type of a car or a vehicle. This is also a type of a person. So these are of the class person. Okay. And anything that you assign to the left of it will be of a variable of that particular class. Okay. Similarly, you can have this as a noun, as a verb, and things like that. That verb and loves and is doing something. So nouns, adjectives in this way, mapping to languages also you can think of. So the nodes, as we were talking about, they are the objects, can have name value pairs, can be labeled, and relationships by type and direction can have name value properties. And we will get into this RDBMS, but as you can see, this relational model here, you have to go from here to here and then from here to this one. And this is a person of a friend of the person, and then you have to get to the friend. So if you have to access this person, you have to access through this particular mapping, which is telling you that this one is a friend of this person or somewhat like that. If you want to find out, you have to go through these mappings. But here, if you see this, he knows this, he knows this, he knows this. Well, that's it. And you have the graph model. So it is index-free adjacency. And I have created a few things for starting with the Cypher, this query language. I wish I could show you. I have 30 notebooks currently with me. I have practiced for the last 3 weeks, and I wish I could show you all of them, but I can't. So this is to create the nodes. For instance, when you are creating nodes without any labels or anything else, you can simply say something like this: match end, return end will display nodes. Why am I showing this? Because you will see these things when I'll get into the use cases, you will see these things coming quite frequently. And I don't want you guys to be on some other universe when we'll be talking about that. So match and return in is just like, I mean, display. I think you have all seen in this, or maybe the data frame dot head. So whatever that is, it is equivalent to this match and return in. If you say 100, 100, match and return in is basically going to return you all the nodes that are currently present in the Neo4j in the browser. I will show you how that is done. And if you want to set labels for nodes, you can set it dynamically as well here. And detach, delete is something which we will be always doing before starting anything, any work, because if there is something which is already there, we'll be actually detaching and deleting it. Rather than going through this, let me actually show you this one. Why not just show you this one? Where is it? So let's say, so let's not go into this tough thing for the start. Let's get into something very small. Yeah. Okay. So this is basically one of the, firstly, you can see how this Neo4j looks like. This is how it literally looks like, right? Okay. Okay, browser sync is disabled. Okay, then internet connection got lost. Wait, I have to stop this and start again. This is the Neo4j desktop version that you can download and install. It's for free. And there is another version, which is the enterprise version. So if I had to install this in that laptop, which is my shell laptop, then in that case, I would have required the admin permissions and all those other things, because they wouldn't allow any desktop version to be installed there. So be very careful about it when you're using the desktop version in any industry, because they might not allow you to use that. So this is one of the things I should tell you. And this is basically the console or browser, not console, I should say. This is the Neo4j browser. Herein, you will actually be able to see when you will actually type the different, you will write the different scripts here, you will be able to see everything. But you can write it from the code as well and see the results here as well. And this is what the beauty is. And using this API, when you call the API, you will be able to do that. Let me see if it has stopped or not. Okay, it takes time. So let's get into this while it is not stopping. Let's get into this thing. So again, we have this for each IND range for creating multiple nodes within for loop. You can just create it, search for particular node within multiple nodes. You can do something like this. And this is a very powerful operation. We will use them. We have in fact used it. So you will see these things coming. I mean, this is something which is self-explanatory, and I think you have all understood what it means. I mean, specific node from multiple nodes. You can use either something like name, ID, whatever is the property there, you can use that in order to search. And what are the pains of SQL? It is a complex to model and store relationships. Performance degrades with increase in data. Queries get long and complex. Maintenance is painful. And graph gains is easy to model and store relationships. Performance of relationship traversal remains constant with growth in data size. Queries are shortened, and we'll see why it is, and more readable. Adding additional properties and relationships can be done dynamically. So this is why it is so like this. Oh, yeah. Yeah. Yeah, absolutely. Yeah, yes, thank you. Yes. Yeah, that gives a wrong picture. Basically, I didn't want to show them that. I wanted to show them that in fact, the companies also, I said it before as well, that they use both. It's a hybrid system that we are right now in. Even in companies like LinkedIn, Meta, Google, everywhere, you will not see that they have completely gotten rid of this. And they are using something sort of a hybrid structure, both SQL and this one. And yeah, so that is the reason why this one is, why what Maharaj said is obviously true. So this is absolutely yeah, TCS is. Mm. Yeah, right. So yeah, so something like this. And so locating the foreign keys and so on. I want to see whether this has come up or not. Let me, oh, just let me start this again. Oh, yeah, it has started. Okay, let me show you this. So you can open this, you can just go here. This is your Neo4J, by the way. You can take this HTTP port. I'm not going to show you the configurations. If you have any question, you can later on ask Sudipto sir, and he will be able to give any question that you have. You can share with me, share with him, and then he can forward them to me. I can answer those questions later. I mean, how installations are done and what all configurations you have to make, because sometimes you won't be able to see this coming up, and sometimes just by taking this HTTP port, this address, it won't probably open up, because there you will find in the settings you have to change the configuration files and so on. I'm not going into that because it's out of scope today. This is so what we are essentially doing, as I was showing you. Where did I? Okay, so restarting the kernel. Okay. Okay, so let's start from this unlucky one, and let's see that uh, we will import this library is required, Neo4j library, and this has the this is the syntax. So graph database dot driver, and you have the URI. This URI bolt address you will get here. Okay, so you can copy this from here, and you'll have to put this is basically like saying you are have you ever accessed Oracle database from using CX Oracle from Python? Anyone has done that in your projects? No. Okay, so if you want to connect it, then that particular one will ask for the DB host name, username, password, and port number, and so on. So once you get those things, once you enter those things, you enter into the database, right? Alteryx, have you heard of Alteryx? Anyone? Nobody. Okay. Alteryx also uses, it's developed on R, by the way. It's easier to use because it's a UI only. Coding is not that much required there, but that one also you can use that one for fetching. I personally use that one in order to, fetch the data from databases. It is easier to connect. I don't know why, but this is what I've seen. It's faster and easier to connect to databases whenever it is required. And you can accordingly write the SQL script over there, and you can do everything. I wish I could show that. So there's an example there. So uh, okay, okay, sure. So basically the thing that I want to show you is like, this is like establishing the connection. Now you've already established the connection. Okay, we are seriously running out of time. A plan for so many things. Okay. So match and detach, delete n. So delete all nodes with all relationships. This is very important. Why I do this? Because I've seen if it has this is what it has. If you see this is a clear local data. You would otherwise have to do this cache clearing. Okay. So it is better to do that right from here. Right from here. Sorry, how to. And here, let's say I do this. I create a node named myself, and this is a pretty bad thing I have written. So as these are the different nodes I have created. You will see when I run this, you will see what will happen. Now, if you just go here and say match n, return n, it will give you this idea. It will give you that this is a devotee, this is a complete loser, and this this is a goddess of wisdom and knowledge, and this is also goddess of wealth and property. This worships this one, this worships this one. So this is exactly what you will see. This is a type of things that we can actually create, and we can delete, and you can also actually see it from here. Like if you want to see what type of relationship it is, you can see right here. And let's say if you want to see that, I mean, what are the different goddesses who are worshipped by this object, you can actually run this and you can see this name, how many counts of it, how many counts of goddesses are being worshipped by that name and so on. So, and this is pretty much obvious because what you can see is that count is giving you the total number of goddesses worshipped by this object. So this is basically giving you the F count or whatever variable, you can say X, Y, whatever that would be, and you can simply do this. Let's come to one of the, I should say, one of the things that I wanted to discuss. Should I cover crime data or CDR? I mean, which one do you want to prefer? Everyone? Yeah, only one is possible. Which one should I do, crime or call data? Crime. Okay. I thought about it. I actually saw that we could do a lot of things around crime. By the way, this is to detect. So what I'm just going to share you one small thing about it, and that I think will be enough. I think that is here, right? Yeah, this is called the pole model. Okay, persons, objects, locations, and events. Suppose there is a particular crime event that has happened somewhere. Let's say a bomb blast, and Chota Shakil was there somewhere in that near that bomb blast scene. Now you can understand what can be the reaction of our government would be towards that Chota Shakil crime, and then obviously the connection is with ISI, not this one, Pakistani ISI, and the connection is with ISI, and obviously Dawood Ibrahim, and obviously the entirety of Pakistan will come into picture, and so there you are. So this is exactly the thing what we talk about, which location and which person was present in which location, and what are the objects which were there. He was holding what? Nowadays, you don't see people carrying bombs with them or AK-47s or whatever with them. You don't see that, of course, if you are not in Afghanistan. So objects would be probably in like smart devices, and also events will be like phone calls. I wish I could have actually shown you. There is something what we call how people actually do crimes. How do actually telecom those who are actually trying to locate criminals, how can they locate? Suppose any one of you, let's take him. Okay, no, you are not a criminal, by the way. Somebody is calling you, and he is from, let's say, Norway, but he's using the internet in order to make a voice call to you. And what happens as a consequence that it does not come to the telecom network provider is completely not present in the middle. What happens is that it directly comes via the internet. As a consequence, what happens is that he gets a lot of, he just, he doesn't call anybody, and he gets a lot of, he calls a lot of people, but he doesn't receive any call. It's very fishy, isn't it? I mean, he is calling a lot of people and he's only in one location, let's say. So this is exactly what police do, or NIA, or these people do in order to actually locate these people. If you are present in one location and you're keeping on calling other people and nobody is calling you, then definitely there is some, these are what we call abnormal activities of callers. So this is something they track. Data transmissions also same thing, that a lot of huge chunks of traffic is coming from that IP. As a consequence, what happens is that immediately they start tracking what are the websites they are, even in incognito mode also, they can track you. You must know this. It's not that they can't. But whatever you are searching, be very careful about it. And the persons can be victims, suspects, witnesses, investigators, anybody. Okay, so this is the model that we are using. Let's go to the program. Again, as usual, we will just restart the kernel and we'll show you that, let's say we run this. And again, this is authentication. Neo4J is my username and this is my password. You can use this password. I know everything is hackable right now. And this is the City of London street data. And so what I've done is that you can see where this is usually stored in this location. By the way, be very careful when you are storing this somewhere. This is, if you try to store it in a particular location, any C drive, D drive, I have personally seen that it throws error. Today, only I have seen this while doing a change in one of the codes here. I have seen this happen. So it's better to keep in a custom location, in the specific location they ask you to put in. And that is why I am putting in all these data in. This is the City of London data. This is actually consisting of the following things. It's not very large. It's only a subset. It's crime ID, month, reported by, false within, longitude, latitude, location. And this is LSOA code. By the way, this is something which I have downloaded and from the UK government crime data website, I mean, UK government website. And LSOA name, this is basically the name of the place. This is a code. And this is a crime type, okay? And this is the last outcome, under investigation or offender given a drugs possession warning or whatever that is. Or maybe it is completely antisocial behavior activity and completely no outcome. Last outcome, there's no result. This can also be there. So we can, what we are doing is that we are reading this as a CSV where this location shouldn't be null, because if the location is null, then there's no meaning of doing all this. And then we are also doing this, and as that we are splitting this month into year month, where year month 0 is not null. And similarly, this one as well, year, this is for place, this is for year. And we are actually doing that crime type should not be null, latitude should not be null, and so on. And lastly, we are doing that, saying that this is actually crimes, CSV.crime ID is null. Then you just put empty here, and then you can, this is basically an if else you can do, and then end, and this is the latitude and longitude and all these things. Okay. So this is literally doing it. What is it doing? Let me show you. So now if you see this graph, or if you try to just see this, it will show you a very, I have actually done something in the past, and that's why it takes some time. Okay, it will take some time to come up here. So this graph is going to display, because I have changed the configurations here to, I've changed the configurations here, and that's why it is taking such a long time. That is not a problem. Okay, just come finally. That is why this is the thing. So I have, don't do this. I mean, connection timeout, and there is also in the properties, you can actually have initial node display. I have put it as 1000. That's why it is showing like this. So better not do this, keep it as 50. But if you keep it as 50, you will find this relationship coming up. So these are the, I mean, different, these orange ones, as you can see, are the cases. And these green ones that you can see are the places, okay? And the pink ones, which are there, these are the categories, antisocial behavior. We have a lot of them here in Bengal. These are the things you will find. But one thing to notice here, there is no such relationship between this you have a relationship between these cases and to which category it belongs and where is the case happening, the place. But the place and the category, they are not actually having any relationship. So this is a hidden relationship, which you may want to find out. We'll see that. Suppose you want to find out the year, let's say 2022, month 9, September, and at what place, which case happened. So if you run this, and if you just simply see this, the records, you will see we are doing it by order by occurrences in the decreasing order, the first 10. So you will find that on or near Bishopgate, occurrences are 27, Victoria Avenue 24, and so on. Similarly, if you go to this one, which also says which category is a type of which case, and you want to be able to see the different types of crimes and their occurrences, how many times that happened, okay, all these things. Then you will probably also want to know which case, how many cases have actually happened. I mean, let's say this is and what is the status of these cases, right? Well, you want to know the status of these cases. So if you want to know the status of these cases, so you will see that under investigation occurrences are 375, and these are also in the decreasing order, and you will see that. We are not putting any limits to that because we have specific number of categories here, so there is no need of putting a limit here. And lastly, if I'm saying that I want to find out the offender given a drugs possession warning, and the category name is drugs, and the place is P, and where is that particular drug possession warning, this case coming at? So if you see this, then if you run this, you will see that on or near Victoria Avenue, on or near Finch Lane, Holborn, Chancery. So this type of crime category, as I told you, this category is drugs, and the case is outcome is basically this one. But you want to be able to find, you want the type of place or the place where this particular type of outcome has happened. That is this outcome, meaning here that you have probably seen that this one has a specific outcome, that whether this particular person has been given a bail and he's out or something like that. So this is what you will probably see here. So these type of things I'm talking about under investigation. So you want to see so this type of thing is, what is the outcome? Based on the outcome, you want to see where they are. And let's say we want to also see because we have seen that on or near Bishopgate had maximum number of crimes. So we want to see which type of crime, I mean, whether drugs has how many occurrences here. So total you count, how many are there? Total has 27. So we'll see whether this actually matches the 27 or not. So you see, this is 19, 20, 21, 21 plus 4, 25, 26, and 27. So these are under investigation, offender given penalty, and so on. And if you again try to see that which category or which case happened at what place, and at the same time, which case is type of which category, and this particular case is type of which category. If you try to return the C.outcome, that is a status, if you want to return, and the category name and the count of distinct occurrences, then order by the limit 10, then you will see that under investigation, on or near Bishopgate, you find that all different types of cases and the number of occurrences. So The category is this, and this is this. Category is this, this is this. And so if you add them all up, you will come up with 27. So this is basically a very high level view of what I may call this Neo4j and how we actually do it in this. But the, yes. Yes, and firstly, the most important part is that this particular file is not having any relationship at all. If you see this file, it doesn't have any relationship. We have to create this, we have to convert this CSV file, if you will, into a graph database or a graph model or whatever you want to call it. So this is what you have to create. This is the hardest part of it. Once you have created this graph model, everything is done. Either CSV file, or you can, like, for instance, if you want to see what are the latest things that are there, latest questions asked in Stack Overflow, there's an API call which you can make. This is a big data. And you can actually see this with this one. You can actually go to that particular URL and fetch all the things, all the questions, answers, tags, comments, everything from there. And then you can understand which are the most frequently asked questions within a span of 2 hours, which is the most frequently asked question, which is for this day, what are the top questions for, what were the top questions in the last month, or what were the top comments, or what were the top, how many number of, in Stack Overflow, you have these upvotes. Right. So how many upvotes were there for? And so based on that, you can do that analysis. This is, again, this Stack Overflow analysis does that. I mean, in order to do this, I had to create this whole thing. So you can either, it can be CSV file, it can be an URL, it can be a JSON file. This is typically a JSON file, by the way. It literally fetches from there the JSON file. This API is literally doing this. It can do anything. It can take any type of file and can convert it, but you must know what are the syntax. Okay. So yeah, please. Yeah, zero relationships, because initially when it actually, the whole thing, yeah, this is a very good question. I also had the same question. And when you actually put this, when you click it here, you will find that there are 2588 relationships. I also was dumbstruck when I could see the entire thing, but nothing was coming out. You just have to click here and then it shows you the whole thing. Yeah. That is a good question. You have to create that graph model. If that relationship does not exist in that data, there is nothing you can do. Whether he studies in RKM Very, if that particular thing is there, if that is there in the data, you could have done that, but it is not there. You can see that his roll number, ID number is there, his name is there, where he's studying, what is his age, and all those things, what subject he's studying, everything is there. But how they are related to each other, how can you establish without creating that relationship? Because whenever you have to create the graph model, you will have to create that relationship. Otherwise, you will never be able to establish it. It won't create it automatically. The question is. In a way, that is true. I mean, it's not always, yeah, it has to be structured, because if you are using images, of course, then you have to put it in a database format. Like you can have blobs and so on. In a in database, in case of databases, you have blobs there, you have to have them as blobs. That is called unstructured to unstructured if you go back. And in case of structured databases, you have to first create that model out of it. Otherwise, you won't be able to do it. because that relationship is not inherently present in the data itself or database per se. Yeah. Hmm. 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 That you have to basically, what happens is that suppose there is this is crime for UK, this is for one city, there is another city, let's say. And if you establish that there is a common node, or there is a, let's say this is a common category, which is also we going to be there in that particular case as well. Yes. So they are in the, you are trying to say there are two independent components. Huh. Hmm. 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 Same is the way. I mean, what will happen is that instead of saying that I am going to take this type of an object, case type object, I'm going to take it from a different, let's say we'll have to rename it as case 1, and that will be case 2. And then you will have to say that this case is related to the category from 2, category 2. This will be category 1 here, and that will be category 2 there. So you will have, you can say that this is basically related to that category 2, which is not even present here in this particular graph. Then you can actually assign a relationship between this case and the category of that particular graph. And this often happens. I can show you one example. It's a very basic example, but I can show you, I think this example is a common example. What you're trying to say is something like this. Let's say this is let's say a person, and these are the different people in his workplace whom he knows. These are his family members. And these are the people whom he studied with in the high school. And these are the people whom he met in a seminar like us today. And these are isolated. As you can see, these are isolated. But if you want to, if you have a relationship between them, if you have, then there will be an edge between them, and that will be a relationship. And then you can easily find out. But if you suppose disconnect this, suppose disconnect this particular thing with this one. Suppose this is, who is connecting this one with the rest of the people here? This bridge node. This is, let's say, the brother of this guy, who is also studying in the same school. So naturally that can happen. So this bridge node is connecting them, or there is there must be a common. This is where we are coming to again the centrality, degree centrality. If you are aware of, then we have several types of degrees, say degree centralities, like closeness centrality, then degree centrality. I mean, how much central it is, how much close it is. I mean, what is the shortest path from this node to all the other nodes in that particular thing? Is my question answered, or or should I give further answer? I actually created this same case. I mean, what you are trying to, I think, ask is that there are two separate components and they are connected by one edge. Hmm. 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 I mean, these two are completely isolated. In that case, if there is no relationship, there's nothing you can do. If there is a relationship, there is a relationship. You are studying here, someone is studying chemical engineering in, let's say, another college somewhere in Ludhiana. What relationship do you have unless you know him or you know a friend of his? There's no relationship at all. So you must have some relationship with that guy. Chemical engineering, and you are studying data science or computer science here. What relationship is there? He will talk about organic chemistry. You have probably scored only 60 there. So naturally, no, this was my score. That's why I'm saying. Yeah. Thank you. Thank you, ladies and gentlemen. Yeah. I just stay 200 meters away from this place. You can come to my place as well, if I'm not working, by the way. Thank you.